Hi, Assalamualaikum and good day. Today you are going to learn on how to integrate the rational functions. This is the objective of today's lesson. By the end of this session, you should be able to state and apply the techniques of evaluating integrals involving rational functions. In this lesson, you will only learn on how to integrate the rational function that are represented by p over q, in which p and q are polynomials. Rational functions can be classified into four types. Type 1 is known as proper fraction, in which the degree of the numerator is less than the degree of denominator. That is, degree of p is less than q. To integrate a rational function of this form, you may use direct integration using either standard formula or use substitution. Refer to example 7. To identify the degree of a function, you need to refer to the highest power. See that the degree of numerator is less than the degree of denominator. That is, degree of p is 1 and degree of q is 2. Thus, this integral consists of rational function in the form of proper fraction. To solve this integral, let u equal to x squared plus x. Then du over dx is equal to 2x plus 1. Substitute both u and its derivative into the integral and simplify. You should obtain a new function in terms of u only, which is 1 over u. Integrating 1 over u with respect to u, you will get ln u plus c, in which it is equal to ln x squared plus x, then plus with c. Proceed with type 2 of rational function. Type 2 is known as improper fraction, in which the degree of numerator is greater or equal to degree of denominator. To integrate a rational function of this form, you need to change the form to proper fraction first by performing long division and express the function as the quotient plus the remainder over the divisor. The integral is then can be solved using either standard formula or use substitution. Refer to example 8a. See that the degree of numerator is greater than the degree of denominator. Thus, this integral consists of rational function in the form of improper fraction. To solve this integral, first, change the form to proper fraction by performing a long division. That is, x squared plus 1 divided by x plus 1. Refer to the first term. To obtain x squared from x, need to multiply x plus 1 with x and bring the answer below. Then, minus as usual. X squared minus x squared is 0. 0 minus x is negative x. Bring the last term below, you will obtain negative x plus 1. Next, to obtain negative x from x, multiply x plus 1 with negative 1. You will get negative x minus 1. Negative x minus x is 0, and 1 minus minus 1 is 2. Here, 2 is the remainder. After completing the long division, express the function as the quotient plus the remainder over the divisor. You will get x minus 1 plus 2 over x plus 1. Integrate these one by one. You will obtain x squared over 2 minus x plus 2 ln x plus 1 plus c as the final answer. Proceed with example 8b. See that the degree of numerator is greater than degree of denominator. Thus, this integral contains the function of improper fraction. To solve this integral, first you need to change the form to proper fraction by performing the long division, that is, x cubed plus x divided by x minus 1. Refer to the first term. To obtain x cubed, from the x you need to multiply x minus 1 with x squared and bring the answer below. X cubed minus x cubed is 0. 0 minus x squared is x squared. Bring the last term together and you will obtain x squared plus x. Next, to obtain x squared from x, multiply x minus 1 with x, you will get x squared minus x. X squared minus x squared is 0. X minus x is 2x. Proceed the long division by multiplying x minus 1 with 2. You will get 2x minus 2. 2x minus 2x is 0. 0 minus 2 is 2, where 2 here is the remainder. After completing the long division, express the function as quotient plus remainder over divisor. You will obtain x squared plus x plus 2 plus 2 over x minus 1. Integrate the term one by one. You will get x cubed over 3 minus x squared over 2 plus 2x plus 2 ln x minus 1 plus c as the final answer. Type 3 of rational function refers to rational function in which the denominator cannot be factorized, or in other words, irreducible. To integrate a rational function of this form, you need to apply completing the square for the qx before using the suitable technique of trigonometric substitution that you have learned in the previous lesson. Following is the process of completing the square and the trigonometric substitution that you may use depending on the expression given in the integral. Refer to example 9a. As qx is an irreducible quadratic factor, we need to perform completing the square. Make sure the coefficient of x squared is 1 before you proceed completing the square. If the coefficient is not 1, need to factorize the whole expression first. To apply completing the square, first write the open bracket, bring the x, the sign, and divide the coefficient of the second term by 2. Then, close the bracket and put power 2. Next, minus the value with the square and copy the third term. Finally, simplify the whole expression. You should get x plus 2 squared plus 3. Therefore, the integral can be written as 1 over x plus 2 with the square plus 3. Solve the integral using the suitable trigonometric substitution. By assuming x plus 2 as capital X, the general expression is capital X squared plus a squared. Thus, the suitable trigonometric substitution to be used here is capital X equal to a tangent theta, in which capital X is equal to x plus 2 and a is square root 3. Differentiate x plus 2 equal to square root 3 tangent theta, you will get dx over d theta equal to square root 3 secant squared theta. Substitute both x plus 2 and its derivative into the given integral. Simplify, you will get a new integral in terms of theta only, which is 1 over square root 3 Multiply with the integration of 1 with respect to theta. Integrate this, you will get 1 over square root 3 theta plus c, in which theta here is equal to the arctangent of x plus 2 over square root 3. Now, refer to example 9b. See that qx is an irreducible quadratic factor. As the coefficient of x squared is 2, you need to factorize the 2 before performing completing the square. To apply completing the square, first write the open bracket, bring the x, the sign, and divide the coefficient of the second term by 2. Then close the bracket and put power 2. Next, minus the value with the square and copy the third term. Finally, simplify the whole expression. You should get x minus 3 to the power of 2 minus 5. Therefore, the integral can be written as 1 over 2 integrate 1 over x minus 3 to the power of 2 minus 5. Next, solve the integral using the suitable trigonometric substitution. By assuming x minus 3 equal to capital X, the general expression is capital X squared minus a squared. Thus, the suitable trigonometric substitution to be used here is capital X equal to a secant theta, in which capital X equal to x minus 3 and a equal to square root 5. Differentiate x minus 3 equal to square root 5 secant theta, you will get square root 5 secant theta tangent theta. Substitute both x minus 3 equal to square root 5 secant theta and its derivative into the given integral. Simplify, you will get a new integral in terms of theta only. Next, expand the term with power, factorize the expression below, and simplify. You should obtain the integration of 1 over 5 tangent squared theta multiply with square root 5 secant theta tangent theta. Simplify this, you will get 1 over square root 5 integrate 1 over sine theta d theta, which can also be represented as 1 over square root 5 integrate cosec theta d theta. Integrate, you will get 1 over square root 5 ln cosec theta minus cotangent theta, then plus with c. In order to change theta back to x, refer back to the trigo substitution. See that our earlier substitution was x minus 3 equal to square root 5 secant theta. Therefore, secant theta is equal to x minus 3 over square root 5. As cos is equal to 1 over secant, therefore cos theta is square root 5 over x minus 3. Cos is equal to adjacent over hypotenuse. By representing this in the right angle triangle, adjacent is square root 5, hypotenuse is x minus 3, and opposite is square root of x minus 3 squared minus 5. In addition, sin theta is equal to square root of x minus 3 squared minus 5 over x minus 3, and tangent is equal to square root of x minus 3 with the square minus 5 over square root 5. Replace this into the answer. You should be able to obtain the following answers in terms of x.